Okay, students. So in the last lecture, we had discussed about Coulomb's law, and yes, we had solved few questions based on Coulomb's law. Okay, so now in this lecture, we'll be discussing about superposition principle. What is superposition principle? And we'll be solving few questions based on this concept. Okay, see, students, in Coulomb's law, the force was being calculated between two charges, right? That means Coulomb's force was given as F is equals to K Q1 Q2 upon R square. Okay, and we had also discussed about the vector form of Coulomb's law. But what is superposition principle and where to use this principle? Okay, see, if more than two charges are given, and if you are being told to calculate the force on any one of the charge, then we'll use this superposition concept. We'll understand this by taking one example. See, suppose, let us say this is your x-axis, this is your y-axis. Suppose a charge q1 is placed over here. Let it be at a position r1. Another charge q is placed over here. Let the position vector be r. Third charge q2, suppose, having position vector r2, r3, whatever, you can take any value. Let us take r2. Okay, so see, in this case there are more than two charges. We had taken an example of three charges, but you can take any number of charges, right? Okay, charge q, position vector r. I'll better redraw this. Say, students. Okay, this is your x-axis, this is your y-axis. I'm placing three charges, q1, q, q2. Okay, let this be at a position vector r1. Let this charge be at a position vector r, and let this be at r2. Okay, so now we are having more than two charges, and now if we are being told to calculate the force acting on charge q. Okay, so when more than two charges are involved and you have been told to calculate the force on any one of the charge, then we'll use superposition principle. That means uh, we'll calculate the force on q because of this q1. It will be in this direction because they are having the same sign. Force on q because of q2 will be in this direction. Hmm? And then these are the force acting on this charge q. Okay, charge q. Now, the vector sum of these two forces, this force and this force, will be the resultant force acting on the charge q. Clear, students? Done? Okay, fine. So, let us say this as 1, 2, and let us say this charge as 3 charge. So, basically, we want to calculate the force on third charge. So, according to superposition principle, force on any one of the charge will be equals to the vector sum of the forces because of other charges. So F3 1 plus F3 2. Of course, see, here we have taken three charges. If we are taking 4, 5, 6 charges, that would be okay. That means we'll use in the same way. We'll use this formula in the same way. Clear? Hmm? Done, students? So force on third charge because of first and because of second. We'll have vector addition of these forces. Now see how vector addition is done. F31 plus F32. That will be the total force acting on the charge F, total charge Q. Okay. Now see, this was the arrangement. This was Q1, is R1. This will be Q R. So force on 3 because of 1 will be equals to K Q Q1, and the distance between them is, let us say it as X. Let us say it as X. Okay, so this will be X. Okay, X. So it will be upon X square into unit vector. Unit vector is to represent the direction of force. Now, see how to find this X. Okay, students. So this is F31. In the same we will calculate F32 also. So this is your R1. Okay. This is X and this is R. Right? So see, from the law of vector addition, R is the resultant of R1 and X. Right? That is R is equals to R1 plus X. Therefore, X will be equals to R minus R1. Got it? Right? So substitute here. So F31 can be written as F31 equals to K Q Q1 upon, instead of X, I'll write it as R minus R1 the whole square into unit vector. Unit vector, that is X by X, magnitude of X, that is vector upon its own magnitude. Clear? Clear, students? Similarly, F32. Similarly, F32. This can be written as K Q Q2 upon R minus R2 the whole square into R minus R2 upon magnitude of R minus R2. Done? Done? So this is how F31 and F32 are being calculated. So total force on F3, total force on F3 will be vector addition. That means addition of F31 and F32. Right? Got it? That means total force F3 will be equals to F31 plus F32. That is KQ will be taken common. Q1 upon R minus R1 the whole cube into R minus R1 plus Q2 upon R minus R2 the whole cube into R minus R2. Done, students? Right? In the same way, if you have been told to calculate the force on any fourth charge, suppose we'll take the example of four charges, Q1, Q2, Q3, and Q4, and if you have been told to calculate the force on any one of the charge, right? That means if this is the question or this is the situation that these are the four charges, Q1, Q2, Q3, say Q4. Q1, Q2, Q3, and Q4. This is your y-axis, this is your x-axis. Now, if you have been told to calculate the force on, say, any one of the charge, let us say second charge. So we'll again use superposition principle because more than two charges are involved in this also. So force on 2 because of 1 this way, because of 3 this way, because of 4 this way. We'll add these three forces. That is, force on second charge will be force on second charge because of 1, because of 2, because of 3. Sorry, because of 3 and because of 4. Clear? So this is basically superposition principle, or you can say extended version of Coulomb's law. That means if more than two charges are involved and you have been told to calculate the force on any one of the charge, then it can be calculated using superposition principle, which states that the total force on any one of the charge will be equals to the vector sum of all the forces acting on that particular charge because of other charges. Got it, students? Okay, clear? Okay, now let us solve one or two questions based on superposition principle. Okay, like suppose, see, suppose you have been told that two charges, hmm, one is say 8 microcoulomb, another is say minus 2 microcoulomb. Hmm? Let the distance be anything. You can take 20 centimeter, 30 centimeter, no problem. That is up to you, 20 centimeter. So see, two charges, one is of 8 microcoulomb and one is of another is of minus 2 microcoulomb. They are separated by a distance of 20 centimeter, right? Find find the position of third charge where net force acting on it is zero. Hmm? Okay, this is your question. You have to find the position of third charge where net force acting on it is zero. Say students, make it clear now. One is positive charge and another is negative charge. Okay, fine. I don't know where to put the third charge, but one thing is sure that Coulomb's law is a central force, line joining the forces. That means Coulomb's law will act again along the line joining the charges. That means this way, somewhere here. Suppose if I am placing a charge Q over here, somewhere here, we'll check whether the force acting on this charge is zero or not. Say what the question says, you have to find the position of third charge. Find the position of third charge where net force acting on it is zero. So if you are placing a third charge over here, then this 8 microcoulomb will repel this Q charge. That means force on this charge will be this way. Minus 2 will be attracting this towards itself, so again the force will be in same direction. That means both the forces are in same direction, so net force will not be zero if I'm placing a charge Q over here. Students, you are understanding this point? Hmm? This is 8 microcoulomb. Let us say this as Q1, let us say this as Q2, and let us say this as Q or Q3. So this charge is exerting force on this charge Q in this direction. Clear? In the same way, this is negative charge. It will be attracting the charge towards itself. So the force acting will be again in the same direction. Since both the forces are in same direction, net force will never be zero. So you cannot place the third charge here. Okay. So this alternative is not possible. Okay. So now let us find another alternative. That means one thing is sure, I'll not be able to place the charge anywhere between the line joining the charges. That means I'll not be able to place the charge between 8 and minus 2, anywhere between 8 and minus 2. Okay, now suppose let me place the charge somewhere closer to this 8 microcoulomb. Let us say over here. This is the point. So this 8 microcoulomb will exert a force in this direction. Minus 2 will be exerting the force in opposite direction. Okay, so see the forces are in opposite direction. But 8 microcoulomb is having greater magnitude than 2 microcoulomb, right? And the distance is also less from 8 microcoulomb. And from 2 microcoulomb, the distance is 20 plus x. See students, don't get confused, make it clear. If you are placing the charge outside the line joining the charges and closer to this 8 microcoulomb point at point A, so of course 8 microcoulomb will exert a force in this direction, and minus 2 will be exerting force on Q charge in opposite direction. Yes, forces are of course in opposite direction, but there are no chance that they will cancel each other because 8, the magnitude is more than 2. Also 8 is placed closer to Q charge, or we can say Q is placed closer to 8. So magnitude wise the force on Q charge because of 8 microcoulomb, it will be greater than minus 2. Clear? So even though the directions are opposite, but the force will not balance each other. Got it, students? So now the left out alternative is, let us place the charge close to minus 2 microcoulomb. We don't have any other alternative now, right? Okay, so if you are placing a charge close to minus 2, say here, somewhere here, let us say this distance be x, this distance be x, this was 20. Okay, see, so minus 2 will exert a force on this charge q in this direction. It will be attracting towards itself. And plus 8 coulomb will exert a force on q in this direction. This direction. Okay, so yes, see, the forces are in opposite direction. Of course, the magnitude 2 is less than 8, but 2 microcoulomb and q, they are placed closer than 8 microcoulomb. You understanding the point? Hmm? That means placing a charge q closer to 2 microcoulomb, there are 100% chances that the force acting on q can be taken as 0, because yes, 2 microcoulomb is having less magnitude than 8 definitely, but 2 is placed closer to charge q, or you can say q is placed closer to 2. So according to Coulomb's law, less the distance between the charge, more will be the force, because it is after all kq and q2 by r square. Clear? Clear? So even though 2 microcoulomb is having less magnitude, but the distance between q and 2 is less, so there are chances that the force acting on charge q may be 0. So one thing is sure, students, when you are having this situation, always place third charge outside the line joining the charges, and close to the charge with less magnitude. Clear? Every time will not check the position of the charge, will directly place. Clear? So if one, only for this case, students, make it clear. That means if one is positive charge and another is negative charge, if this is the situation, then always place the third charge outside the line joining the charges and closer to the charge with less magnitude. Got it, students? Now let us solve this question. You have been told to find the position. That means you have been told to find the value of x, where the force acting on q is 0. So let us say this has your third charge, this has second charge, and this has first charge. So force on third charge, see, we are using superposition principle, equals to force on third charge because of 1, because of 2. Got it? You have to find the position of third charge where net force acting on it is 0. That means F3 is taken as 0. F3 1. So that will be K into 8 microcoulomb Q microcoulomb upon total distance will be 20 plus X the whole square plus K minus 2 Q. It's done. Okay, if I'm taking the term over this side, this will be 8kq 20 plus x the whole square equals to 2kq by x square. There is no need to convert microcoulomb into coulomb because it will be cancelling each other. Will be cancelled out. Kq gets cancelled 4 times. Okay, so finally it is 4 upon 20 plus x the whole square equals to 1 by x square. Okay, so on solving this, see, This can be written as 2 by 20 plus x the whole square equals to 1 by x the whole square. This will be easy to solve. So it is 2x is equals to x plus 20. So x is 20. Got it, students? So this is how we'll calculate the position. Hmm? Done? So this is how superposition principle is used. Now, I'll give a shortcut for this sum. See, you can calculate this sum. I'll give you two shortcuts. First is, let us say, case 1. When one is positive and another is negative. Like 8 microcoulomb minus 2 microcoulomb. This was 20. Okay. So this can be also calculated as x is equals to r upon root of bigger charge upon smaller charge minus 1. See, 20 root of bigger charge is 8, smaller charge is 2 minus 1. So it is 20 by 8 by 2, that is 4. Root of 4 is 2. 2 minus 1 is 1. Clear? So direct answer is 20. So students can also use this shortcut for their competitive exams. Clear? But yes, x equals to r upon q bigger by q smaller minus 1. This is to be used when one of the charge is positive and another is negative. If both the charges are positive or both the charges are negative, then we'll use different formula. See, this is 20 by root of 4, that is 2 minus 1, that is 20. Got it? Clear, students? Okay, now case 2, that means what if both the charges are given positive or both the charges are given negative? In such cases, how to calculate the position of third charge where the net force acting on it is 0? That means if suppose you have been given 8 microcoulomb and say plus 2 microcoulomb. Okay, this way. Let us say this distance is 20. Then always place the third charge somewhere inside the line joining the charges and close to the charge with less magnitude. That means somewhere here. Okay, suppose I'm placing a charge here. So this will be x. Say students, when both the charges are either positive or negative, then always place the third charge inside or between the line joining the charges and close to the charge with less magnitude. So this will be x can now be calculated as r upon q bigger by q smaller plus 1. That is 20 by root of bigger by smaller 8 by 2 plus 1. That is 20 by 8 by 2, 4 root of 4 is 2, 2 plus 1, 3. So, got it? So this formula is to be used, that is x is equals to r upon bigger by smaller plus 1. This is to be used when both the charges are either positive or both the charges are negative. And this formula is to be used when one is positive, other is negative. So these are the two shortcuts. You can directly calculate the question based on using this formula. Clear, students? Done? Okay. Now we'll discuss another example where we'll use superposition principle. See, suppose it's an equilateral triangle. Equilateral triangle. A charge minus q, q, q. Let the side be of length L. It's an equilateral triangle. Now we are being told to calculate the force on each of the charge. Let us say this as first charge, this as second charge, this as third charge. Find force acting on each of the charge. Okay. So of course, if you want to calculate the force acting on first charge, it will be obtained by superposition principle. That is force on first charge because of second because of third. Similarly, force on second charge will be obtained by superposition principle. That is force on one and force because of one, force because of three. Suppose I am calculating force on this charge first. So 2 will repel this charge in this direction. So this will be force on 1 because of 2. And minus will be attracting this charge. So the force will be in this direction. That is force on 1 because of 3. Hmm? Since the triangle is equilateral, so it means this is this is 60-degree, right? So the angle between two forces will be 120 because total is 180. Okay, so this angle is 120-degree. Hmm? So magnitude wise, F12 is equals to K Q by L square. And magnitude wise, F13 magnitude wise, students, will be again equals to Q by L square. I'm talking about magnitude, so I'm not taking negative sign. That means magnitude wise, F12 is equals to F13. Let us say this as F. Okay, so one force is F13, another is F12, and the angle between them is 120. Okay, so the resultant will be obtained by parallelogram method, law of parallelogram, vector addition. Right, resultant will be somewhere this way. Got it, students? This is how we'll calculate the resultant. So resultant force on first charge will be equals to root of a square, that is a square plus b square plus 2ab cos theta. Cos theta, that is cos 120, that is it is root of f12 the whole square plus f13 the whole square plus 2 f12 f13 cos 120. Okay, students, so this is equals to root of f square plus f square plus 2f square. What is cos 120? Minus 1 by 2. So it is f square plus f square minus f square. So it is equals to. So magnitude wise, the force on one will be kq square by l square. Got it, students? Clear? Done? In the same way, force on second charge will be obtained in the same way. That means one will be exerting force on two in this direction, and 3 will be exerting force on this direction. So resultant will be in this direction. Answer will remain the same method. You will do it by yourself. Hmm? Okay, now let us calculate the force acting on third charge. Okay, force acting on third charge. See, magnitude wise, students, magnitude wise, all the forces are equal. Magnitude wise, the forces are equal. So now, force on third charge because of 1 and 2. See, 3 is negative. So 1 will attract 3 in this direction. This will be force on 3 because of 1. Similarly, force on 3 because of 2. And the angle between them is 60. See, this is to be noted down, students. Now the angle between these two vectors is 60. So again, F31 magnitude wise, F31 equals to kq square by L square, which is also equals to magnitude wise F32. Let us say this as magnitude wise F. So again, we can use the same formula, that is law of vector addition. Magnitude of F3 equals to root of F square plus F square plus 2F square cos 60. So this is equals to root of F square plus F square plus 2F square. What is cos 60? 1 by. Clear? So this is finally equals to root 3. Done, students. So this is how we'll calculate the magnitude of force acting on each of the charge by using superposition principle. Done. Fine, students. So now in the next lecture, we'll discuss about very important topic, electric field. Clear? The later half of the chapter is based on electric field. Thank you.